This is Unit 4, Access Control Part 2. In this lecture, we're going to talk about techniques of access control and introduce full-on the access matrix, which is a very handy method of representing access rights and leads us to both the concept of the access control list and that of the capability. Access control techniques and technologies. These are the techniques that support the access model chosen by the organization, whether it's discretionary or mandatory. You can have rule-based access control, constrained user interfaces, the access control matrix, which is actually not so much a technique as a method of describing access rules, content-dependent access control, and context-dependent access control. Rule-based access control. It's based on if X then Y programming rules. It's based on a certain amount of logic, not just a simple comparison, but potentially very complex rules. It can be based on the identity of the user or subject, but it can also include other criteria, like time of day, nature of content accessed apart from any access control lists associated with it, and so forth. Now, constrained user interfaces are something that's often used to restrict access to only authorized functions, data, etc., but they do come with a very important warning. Some examples of constrained user interfaces include restricting users to functions presented on a menu. You often see this in application software, older style software, where they're basically just given a toolbar, drop-down menus, and that's all they can get to. If you go to, say, a kiosk type function in a public area, you've often got a menu, and they try to make it very, very difficult for you to break out of this menu and execute anything that's not on the menu. That's a constrained user interface. You can give folks a command line, like a DOS shell or a Linux bash shell or whatever, and then lock it down so that only certain functions are allowed. You can provide folks with access to a database even using a general purpose query tool, but you can restrict them from accessing the underlying tables and only present certain views or combinations of tables that may restrict columns and rows based on what the user is allowed to see. And then you can restrict the physical interface. Think of the example of an automated teller machine, where the only functions a customer can execute are those presented by the buttons that are physically available to the user. Other types of programming buttons, etc., require somebody with secure physical access to the inside of the machine to actually reprogram it. And finally, certain URLs in web-based applications. This is something that's often done in web-based applications as you try to restrict it by only allowing certain users to view certain URLs. This can be a bit dangerous because there are crafty ways of finding URLs you're not supposed to see, and if you don't secure the middleware, the business logic, and the back end, you may find yourself in some serious trouble there. Which brings us to the last point. If the back-end data or transactions are not also secured, there is a risk the user may break out of the constraints. In fact, my own opinion is you should secure the back-end first and use the constrained user interfaces to supplement that, to make it a little easier and a little tougher for the user, but you shouldn't rely on restricting a user interface. There's just been too many ways over, many, many years for folks to get out of this. Now, the access control matrix. This is a matrix where you have on the rows, you have the various users or user categories or categories of subjects. In this case, I'm doing programmer, sysadmin, and user change control folks, and then everyone else. And then the columns represent resources or objects in the system. The cells are the access right. Programmers can execute operating system executables, basic commands. They can read, write, and execute development programs because it's their job to write code. They can look at production programs but not execute them because they may want to compare what's in production with what's under development. And sometimes they're given read access to production data, where they may need to use this for testing and so forth. Though generally this isn't a good idea. You want to give programmers a sanitized version of production, so they don't end up walking out the door with your customers' credit card numbers. But this is just an illustration. So you can see where you've got users, you've got resources, and in each cell tells you for a user resource combination what the rights are. This is generally used to describe discretionary access control models, but it may be useful for some certain cases of mandatory access control. Think of this as being labels, and you've got a matrix of subject labels and object labels, and your MAC rules are described as a sort of matrix. Now, the capability table is one way of viewing this access matrix. It's basically a view based on the user. Associated with the sysadmin is a bunch of capabilities. This has the write execute capability for operating system executables, the read capability for development program, the read capability for production program, and the read capability for production data, because they're a sysadmin. They need to run commands, but in an ideal world, you'd lock them out of the applications in the production data. Whether this is feasible in most operating systems is a different matter. The capability table binds authority, meaning access rights, to the subject, meaning the user. Some real systems have actually implemented this on the inside. Their operating systems actually have capabilities that are attached to the user that the operating system uses to check authorities. The old IBM System 38 and AS400 tended to use this. It allows you to easily shift user rights. If your system admin needs to temporarily have elevated rights, you just swap out the capability, give them a new capability with the enhanced rights, let them use that for a while, and then take it away and give them the old one. It also allows users to lend their capabilities to other users. If I'm a sysadmin, I may temporarily grant, all other rights being allowing somebody else my own capabilities. It makes it easier to manage rights from the user point of view, but harder from the object's point of view. If you want to figure out who has access, say, to an operating system executable, you have to go through everyone's capability. Think of a capability as a ticket or a token. It's sort of like a key ring, where you've got all the keys to your house, the keys to your gate, to your garage, and they grant access to different sorts of locks. And if you were to loan your key ring to someone else, they would have your access. A Kerberos ticket might also be thought of as kind of a capability. It grants somebody, a particular user, access to a particular resource. Now, access control lists are defined for the object and associated with it. Most modern operating systems use access control lists. Windows uses it, and Unix-based ones, including Mac OS X. Unix permissions are a very simplified form of ACL, or access control list. They have owner, owner's group, and everyone else. So it's a very simplified sort of grouping there. The access control list, for example, associated with development programs, allows programmers read, write, and execute, admins read, end users execute, because that's what end users typically do. Change control can read development programs because they have to move them into production, and nobody else should have access to development programs. Here's an example of an access list, a summary of the access controls actually associated with this particular PowerPoint presentation up here. You can see the different users are defined. Administrators have full control, system and internal user in Windows. You then have the category of users, which, since my machines at home are on a domain, the domain's name is Jackson, after one of my dogs. And domain users have read and execute access to this particular PowerPoint presentation. And then authenticated users have modify permissions to this presentation. You can look up the access control list for pretty much anything in Windows just by right-clicking on the object itself and looking at properties and bringing up this tab. Access control techniques and technologies. Content-dependent access control is where the access is defined based on the content of an object. The access control mechanism looks at the internals of an object and sees what's inside of them. For example, is there account information? Are there credit card numbers? Are there social security numbers? Is there stuff inside it that should be classified at a higher level? Say top secret, you may have a very lengthy essay stored in a word processing system that has certain paragraphs in it that are classified. Content-dependent access control will look inside, find those paragraphs, and execute the appropriate access control mechanisms. Something called data leak protection has been very popular the last few years. What this does is it puts gateways, or in effect sentries or guards, at the exit points for your company's network, looking at email, looking at file uploads, looking at stuff that exits the network, checks out the content of what's going, and if it matches certain patterns, if it's, say, a customer credit card number, an employee social security number, something of that sort, or something that has a label on it that says this is a trade secret, the data leak protection programs will attempt to prevent that from exiting the organization. It's a way to deal with folks who will email out sensitive documents or, in violation of policy, use some sort of online file sharing service to store them, a Dropbox type of thing, and so on. The context-dependent access control looks at the overall environment in which access is desired, including the prior history of the subject's actions. Stateful firewalls can be said to use this. They permit or deny traffic based on a type of prior traffic. If you try to send, say, a TCP packet through a stateful firewall and you have not gone through the initial three-way handshake, the stateful firewall knows it because that context is missing. It's saying, hey, we're getting a SYN packet being sent through the firewall and there was no SYN-SYNACK exchange previously. It'll drop it. So that's context-dependent access control. Firewalls often tend to do that. And that's it for this presentation.